In this presentation, we're going to look at some methods for solving equations and inequalities that have absolute value in them. And we're actually going to kind of limit ourselves a little bit. We're going to look at the case where we have the absolute value of some expression is either equal to a number, greater than a number, or less than a number. And these methods are all going to kind of be similar to each other. So let's see what happens with the equals case. In this situation, there are actually two equations that I'm going to solve. I need to solve the equation 2x plus 6 equals 5. And I need to solve the equation 2x plus 6 equals negative 5. All right, and the idea here is if I can come up with a value of x that makes this expression inside the absolute value equal to negative 5, then when I take the absolute value of it, it's going to be equal to positive 5. So I need both of these numbers. So on the left-hand side here, I'm going to subtract 6 from both sides. That's going to make this 2x equals negative 1. And if I divide both sides by 2, this becomes x equals negative 1/2. And you can check this, right? If you stick this in here for x, this becomes the absolute value of 2 times negative 1/2 plus 6. That's equal to negative 1 plus 6. That's the absolute value of 5, which does simplify to 5. All right, so let's look at what's going on the right-hand side. Over here we get 2x equals negative 11. X equals negative 11 halves. All right, so suppose we try checking this. If I put negative 11 halves in there, this becomes 2 times negative 11 halves plus 6. The 2's cancel here. This becomes the absolute value of negative 11 plus 6. That's the absolute value of negative 5. And that also simplifies to positive 5. So both of those numbers, negative 1/2 and negative 11 halves, are solutions to this equation. All right, so with the second type of situation, I have the absolute value of an expression is greater than a number. And my approach here is actually going to be kind of similar to what happened with the equations. I'm going to solve two inequalities. I'm going to solve the absolute value of, I'm going to solve 2x plus 6 is greater than 5. And I'm going to solve the inequality 2x plus 6 is less than negative 5. All right, so compare this to what we had with the equation case. Right over there, I took the expression inside and set it equal to this number. And I took the expression inside and set it equal to the opposite of this number. And that's what I've done here. Over here I have the number. Over here I have the opposite of the number. And the big difference here is, you notice over here I used the different inequality. Instead of greater than, I used less than. All right, so let's look at what happens. This is going to become 2x is less than negative 11. X is less than negative 11 halves. And over here I get 2x is greater than negative 1, or x is greater than negative 1 halves. All right, so let's think about what this looks like. All right, suppose I want to graph this. I'm going to do negative 1/2 and negative 11 halves. And for this inequality, I need the numbers that are greater than negative 1/2. So that's everything over here to the right. And for this one, I need everybody below or less than negative 11 halves. So those are the numbers over here to the left. And now I have to think about what I'm going to put here at the endpoints, right? Because we have strictly greater than, I'm going to put parentheses here and parentheses here. All right. Remember, if we have greater than or less than, you use parentheses at the endpoints. And if we have greater than or equal or less than or equal, then you use these square brackets at the endpoints. All right, so one important point I want you to keep in mind here is for the solution, we're talking about the numbers that are less than negative 11 halves or greater than negative 1 half. The numbers that fit into either of those ranges are going to be our solutions. All right, so this brings us to the third case. Now we have the absolute value of an expression is less than a number. And this is kind of the nice one. We need two inequalities here, just like we had before, just like we had two equations in the first case. Only what makes this one nice is that I can actually combine these all into one expression, what's called a compound inequality. So what that's going to look like is I'm going to have negative 5 less than 2x plus 6 less than positive 5. You can see what's happened here. We've got the same pattern, right? I have 5 over here, and I have positive 5 and negative 5 in my solutions. All right, so the process now follows the same pattern. I'm going to subtract 6 from both sides. This becomes negative 11 is less than 2x is less than negative 1. And I'm going to divide everybody, all three parts, by 2. And I get negative 11 halves is less than x is less than negative 1 half. And there's my solution, all right? So if I try to graph this just like I did before, I have negative 11 halves, negative 1 half, and here I want the numbers that are greater than negative 11 halves and less than negative 1 half. So those are the numbers that are in between here. And I'm going to use the same end markers. I'm going to use parentheses because we still have strictly less than in our inequality. All right, so I've summarized the procedures that you follow here for each of those three cases. If we have equality, then you use the expression is equal to a or equal to negative a. If we have greater than, you do greater than a or less than negative a. And finally, if you have less than, this is the case where you get a little lucky and you can put everybody together. You do one compound inequality and you get the numbers between negative a and positive a.